Hello everyone, I'm Brian Kopack from Formtek and welcome to Formtek Talks. In today's podcast, I'm joined by Kevin Enos and Charlie Burgess, and our discussion focuses on servo feeders, specifically how they function with press strokes and cycle rates, and the various things you need to consider when deciding how to select them for your roll forming process. Thanks again for joining us. Hello, my name is Brian Kopack and welcome to Formtek Talks. Today I have two guests, Kevin Enos and Charlie Burgess, both with the Formtek group of companies, and we're going to talk about servo feeders. And I think I'm going to start off. Servo feeders, when it comes to a roll forming application, is typically used when we have to do pre-notching or pre-cutting type operations. So based on that, Kevin, tell us a little bit about some of the advantages or features of various servo feeders and why you want them. There's lots of things to consider when you're talking about a servo feeder. Let's just start with the basics. What are the basic things you guys need to know when somebody comes to you with a servo feeder type application?
So the biggest things are going to be for sizing the unit first and foremost. So the material thickness, the line speed, feed progressions or feed lengths, and that's all that's going to go into considering and being able to size the motors and the roll diameters and things of that nature. The backing up a bit, servo feeders ultimately are the replacement for mechanical feeders, gripper feeders, things of that nature, rack and pinion, more chance for marring the material the way you have to transfer it, far more limitations on making changes to those feed lengths, things of that nature, set up by the operator or maintenance personnel. The mechanical or cam driven, that's a very difficult process. When you have to be precise in the feed lengths, that is very difficult to dial that in. A gripper feed is not ideal for applications where you can have scratching or marring on the material, where basically you're grabbing the material or pinching it on the sides or possibly the middle, dragging it a fixed distance, and then letting go and rotating back to position. A servo feeder, by far and away, is the simplest, easiest, and most accurate way to convey material from point A to point B. You can make adjustments to a feed length in process at 1/1000ths. So you can plus or minus. So if going back to your whole location, if you're missing by just a bit, you can adjust that while the machine's running, plus or minus 1/1000ths at a time, in putting in job numbers, which you can't do with any of the aforementioned ways of feeding material from point A to point B. Roll finishes, again, are a factor for the pinch rolls. If you've got surface critical painted pre-paint material, the roll finish is going to be critical to ensuring that material does not get marred or scratched. Repeatability of the unit, and we tend to get into roll repeatability versus part repeatability. The distinction is on the accuracy of the unit is plus or minus 2/1000ths. So if you were to scribe a line on your upper and bottom pinch roll, you put in a specific feed length, those based on the circumference of the rolls, then you should have those 2 points meet back up after a full rotation. On a gripper style or cam style, there's no way to achieve that level of accuracy. The reason that we say roll repeatability versus part repeatability is there are other things, if there's other coil conditions, for example, other than coil set in the material, the chance that you're going to be able to repeat that feed length each and every time is less achievable, not because the machine is incapable, but because of inherent conditions in the material. So those would be the biggest factors. Roll lift would certainly be another factor. The various types, as was discussed in a different episode where we talked about feeders with pull-through straighteners. So there's different configurations that you can utilize. And then finally, with a servo feed, you could do a 2-roll or a 4-roll servo feed. Again, that's going to be application driven based on a 4-roll feed. You have twice the amount of surface contact with half the amount of air pressure, thereby mitigating the chances you're going to scratch or damage the surface critical material you're trying to feed into a roll former or a press.
Is a 4-roll feeder more precise in terms of your feed length and accuracy because you have that dual grip on the material?
It can be. It does decrease the chance for slippage. By design, it's not any more accurate than a 2-roll feeder. The accuracy, the roll repeatability is the same. The difference is by utilizing half the air pressure, you're pulling up that weight. There's less chance you're going to have roll slippage as a result versus a 2-roll where you have to have more pressure with just 2 rolls carrying that material from point A to point B.
And tell us a little bit about, we were speaking offline and we were talking about cabinets versus mounting the servo feeder directly to the press with a shelf. Why would a customer choose one of the over the other? Obviously, if their press had nowhere to mount the shelf, that could be a determining factor, but is there a benefit to mounting the servo feeder on its own cabinet?
The benefit, there's not a whole lot. It's more customer driven and customer preferences as to being cabinet mounted, which would be a standalone unit, or mounted to the press itself. The biggest advantages of having a standalone unit is you're not subject to any vibration from the press itself. That vibration could translate into misfeeds, inconsistent feed lengths, things of that nature. Accessibility to the press window would be another detriment of having a press mounted unit. So most customers nowadays opt for a cabinet mounted unit. You're not subject to the same vibration. We do tie bar to the press to ensure, at least in a press application, you're going to have some inherent movement of that press. The feeder, we need to be able to follow that inherent movement of inertia in the press that allows to maintain a consistent feed length and accuracy of that feed length. So those would be the biggest advantages of one over another. In both cases, I would recommend having adjustability of those units so you can adjust your pass line height. A lot of folks do not have consistency in their dies where you're in the press
Correct.
itself, so you would have to modify the location, pass line location to accommodate for various die heights. Feeding into a roll forming application, certainly having that mounted on a shelf directly to the roll former, you're not dealing with a lot of those same issues you're dealing with a press. You're also typically dealing with narrower widths with a roll forming machine than you can get into on a feeder, or on a press.
Tell us, on the note of accuracy and roll movement, you can definitely control, and you're down into the thousands. When a customer says, "Hey, I absolutely have to have my holes lined up to a thou or less," I know there's such a thing as a pilot hole reference and opening and closing of the servo feeder so that you can let the strip move with respect to the additional pilot hole that's in the die. Tell us, you obviously have that option, but is there some things that you're doing special there to accomplish that?
It's nothing special. It is, as you said, being able to, whether it's in a piloting in a die, for example, we have to be able to open those pinch rolls to allow that material to settle into a location. That's going to ensure the repeatability from the hole to hole location. And that's done, of course, typically via an encoder on the wheels or the rolls themselves to denote the location. So it does have the ability to move, quote unquote, forward or backwards to accommodate for localizing that specific hole location.
And that's probably the most accurate style that you could get, right?
Absolutely.
I mean, so that's a feature that a customer could add, provided that they have the correct accommodations in the die itself that they could utilize.
So the pilot is the most accurate?
I think the pilot is the most accurate.
Yes.
I think there's other ways to get close to that, and I know we've we have used where we actually put an encoder on the material, and we're looking at the revolutions of the servo feeder, and we're comparing the two. And obviously, we're trying to see if there's slip. We use the encoder on the material as as a pseudo closed loop situation where it's the master, and we're looking at what the servo feeder is saying it should have moved, and we're comparing the two. And if it gets way out of whack, we can either throw an error code or let somebody know that something's just not right, but we can still follow what the encoder on the material is doing.
Correct.
See, because in my mind, when you open up the feeder roll, it kind of loses its relationship to the strip, because you're allowing the pilot to move the strip wherever it needs to be in order to get the accuracy on your holes. But the feeder, I know you're just opening and closing, but if that strip does move, now it's moved relative to where that feeder thought the strip was. And that's why I always thought that was not a great application.
Well, I think when the servo feeder closes, and correct me if I'm wrong, Kevin, when the servo feeder closes back down on that material, it essentially is re-zeroing its movement from that point.
That's correct.
So it says it moves another 5 inches or 8 inches or whatever the length is, and then it's going to wait for the die to kind of close and start grabbing the material and then let go of it. So it can move to where it needs to.
Exactly correct. And I would add to that, to Charlie's point, the reason it doesn't lose the accuracy is the fact that you're doing the measurement, the critical measurement is from hole to hole and not necessarily on the feed length at that point. So the reason for opening those rolls and re-zeroing is what's going to ensure we're going to feed the specific amount, but the piloting is what's going to ensure that the hole location, again, you could have other coil conditions where the feeder is showing it moved that material exactly where it was supposed to, but the orientation from hole to hole could still be off as a result of some other material problem. So the other thing to Brian's question would be what we call batching and gagging. So it's not necessarily hole to hole, but you may have an application, whether it's punching on a roll former or some other application where you're going to move the material in increments of 2 inches and then 2 inches, and then your next couple of punches or movements may be 3 inches. So there's going to be a pattern or a grouping of movements that have to follow. So again, going 2, 2, 2, and then you have a couple of 3-inch movements, and then you repeat that process all over again. So another advantage with the servo feed is the flexibility to provide that type of capability that is not the case with the more mechanical type of feeders.
Hitting on that a little bit, there's a feature that is always offered on the servo feeders called Programmable Pattern Control. And that is, I think, when you get into kind of the indexing you're talking about, where it varies a lot through the length of a single part. But where is that cutoff where you need programmable pattern control as opposed to not having it?
That's customer driven. So every application being different, some are going to require that type of movement and that type of a pattern versus other applications that do not. They are facilitating a fixed distance or feed length each time, and not an inconsistent grouping of feed length. So it's really more application driven than it is anything as far as what we would offer or not offer. Inherent is our ability to provide it, but not every customer has a utilization for it.
So anytime you have any non-consistent pattern, you have to have programmable pattern control. As long as you're hitting the same distance on the same hole throughout the length of the part, you don't need it. But if you have any kind of variation in hole spacing, then you need to have that feature.
That's an inconsistent pattern that in and of itself is a pattern, yes.
Okay. All right.
So I'm going to throw out a question that I get asked all the time is, why do we put a servo feeder on the entry side of the press where some people will put it on the exit side of a press? So it's on the entry side, you're pushing material in. On the exit side, you're pulling material in. In my mind, there should, in theory, not be a difference to the servo feeder if it's pulling or pushing. But if you're applying die lube on the material, in your punching process, I could see that being harmful to the servo feeder rolls and its grip on the material if it's on the exit side of the press. Because now it's pulling this material and there's lube on it. So it could increase the chances of slip. Can you think of any other reasons? Is that beyond that, is it really just customer preference, or is there a technical reason?
It is not, in that case, predominantly not a customer preference. The reason for it, and again, as I'll use a press as an example, the reason it's located on the entry side in most instances is the fact that you are facilitating that material into a die. Once you've whatever that die pattern is, punching a hole, making a part, once it does that process, there's less material to work with on the other side or the exit side. Then you get into things like lube. There could be vinyl application, any number of reasons. So the vast majority of the applications have the feeder on the entry side of the product because you are having other processes done on the other side of those rolls, if you look at it that way. Conversely, if we were located on the exit end, we would be feeding out a skeleton of material. And what you're going to get as a result of that is different than what's on the inside. Plus, if you have any issues in the die itself, that could create problems on the exit side feeder versus one you wouldn't experience on the entry side of the feeder. So it is more driven by the fact that there's something occurring after the feed rolls where the precision required is induced at the entry side and not on the exit side. Now, that being said, there are applications that do require the material to be pushed or pulled from the exit side to another, a secondary operation. So there is what's called a push-pull feed, where you're bringing that material in via a feed on the entry side, but then also require a powered feed on the exit side to get that material through the die out to, so again, you're the skeleton, to another operation, rewinding or otherwise.
Okay. And tell me a little bit about the servo feeders that essentially have touchscreen control versus non-touchscreen. Is it something that the operator can just work directly at the machine and do the programming versus doing the programming on a computer and downloading that?
So the feeders, all the feeders today have an HMI, and that's because they can be operated independently or as part of the entire line. And there would be opportunity to set up a job number, for example, at the feeder, which you cannot do at the straightener end. Conversely, there again, the micro adjustment of plus or minus a thousandths, for example, typically that's done at the feed end because you're close to the die or close to the roll former. You can see the impact to that and the adjustments that are made. Unfortunately, in today's marketplace, with the result of fewer employees, the automation factor becomes of greater need. So the ability to, at the front end of a line, at the straightener or the leveler, for example, being able to set it up by job number where everything is done at the feed control and transferred down to the servo. So there's various levels of integration and automation that can be done, but almost all of them now are done at the feeder via a part number, could be a barcode scanner, again, a various amount of methods to accomplish that. But the benefit of being able to do it right there at the feeder is certainly advantageous, as you can get into some pretty good distances from one piece of equipment to another on a larger line.
Mm-hmm. Tell us a little bit about the maintenance on servo feeders. Obviously, the roll diameter should, in theory, never change. That would keep your accuracy at a certain level, but obviously if it's always moving material, it's wearing. Is there a way to recalibrate a servo feeder after the rolls have worn so much, or is your basic recommendation just to put new rolls on the servo feeder?
Ideally new rolls, because typically there's a finish associated with that roll, and the portion that wears out is going to be associated with that finish. As I cited earlier, the example of scribing the two lines, top and bottom, that being the quickest way to be able to determine if there is variation from the time that machine was originally purchased to how it may be operating today. The rolls could be reground and recoded, and you're back to square one. The chances that you're going to duplicate the original drawing, you may be off slightly, and again, you can, via the machine controls, you can adapt to what that variance may be. Do see customers that have, no matter what, experience slippage. They may over or under set the feed length to accommodate for that as well. So there's a couple of ways that people do it. Ideally, to replace the rolls, that would also then afford you less downtime and having a spare set of rolls. So when that has to be done again in the future, it would not impact negatively the production timeline on a project or a process, having to wait for rolls to come back.
So there's an offset feature in the controls that you can use to adjust for the wear.
That's correct.
Now, how does somebody know, other than just making the rolls, that they've worn? That's basically what they have to do.
That's going to give you your best determination. They would typically notice plus or minus variation. So normally you would see, if there's an issue with the feeder, you're going to see a plus variation. If you've got roll diameter changes, you may see plus and minus, and that's going to be a good indication, just visually even, of determining whether or not you're seeing a problem there to start investigating. But miking the rolls is the best way to determine whether or not there's been a change to that diameter. The roll finishes, I mentioned before, being an example, and we tend to talk about that as RMA, which are peaks and valleys on the pinch rolls themselves, and that's what gives you the grip on the material. That will, as you think of it in the terms of peaks and valleys, that will degrade over time. I think in most instances, those pinch rolls will last, the feed rolls will last quite a long time, but over a year or two or three, certainly then you may have to look at replacing those, or again have them reground and refinished.
What about roll pressure? Do you ever have the need to adjust that for not just wear, but for production purposes?
Very rarely. The roll pressures are a factor, but less so overall compared to other parts of the machine. The biggest issue is having balance pressure from one side to the other, so the material isn't being skewed one direction or another. And then there's also the roll finish type materials. So for example, there would be some applications where instead of two steel rolls, you may have a steel bottom roll and an upper roll of a different material, a hardened rubber, for example. So you may see less of an impact to air pressure on a rubber roll than you would with two steel rolls. So you would tend to see the pressure adjustments more associated with a more formable roll, softer roll than you would with the harder materials.
So you might use rubber like in a pre-paint application?
Correct.
But then that would probably also have a higher wear rate, I would assume,
than steel, absolutely.
So you better keep your eye on it if you're in a rubber roll type application.
That's correct. And they do make different types of materials based on hardness. So there's 50 different types of rubber rolls as well. So it sounds simple in theory, but if somebody orders the wrong material, they're going to see an impact to that right away, and that's where you may get into having to adjust air pressures to accommodate for a softer or a harder material. You would also see more wear and tear if you've got burrs, for example, on the steel that are going to cut into that rubber material versus not being the case with hard steel.
Interesting you brought that up. I've also heard that because you run a multitude of widths of strips, that there's strategies for wear on rolls, on how you run the material through, as far as, like, if you always ran a bunch of narrow material, that area of the roll is going to wear. And then if you run a wider material, you're in an area of the roll that saw very little work that you can sometimes have problems there?
You can, and you literally have to be running, we'll just say for a conversation, 2-inch material 80% of the time to notice a difference. With that being said, it still shouldn't impact the overall performance, because on the wider material, the surface contact area is not going to see the same wear as that 2-inch strip area would be running on a normal basis. I think kind of related to that problem is really more with where you're running the material. All the material should be run through the center line of the machine and not off to one side or another, because that will impact the balance, if you will. It does afford the opportunity to skew that material to one side or another. And your issue or your question about the roll pressures then also become a factor. You have a specific thickness of material on one side and no thickness of material on the other. So it definitely presents more opportunities for problems than almost anything else.
Okay.
Well, one last question that I have, and that's going to be based on or directed towards the performance of a servo feeder, specifically your feed length, how fast you can move the feed length through the die, and the cycling of the press. When I've looked at various charts in the past, it seems like it's dependent on the engagement of the die versus the rotation of the ram, where it's at in a certain degrees, and how fast you can go. Talk a little bit about that. Do you have a lot of customers that get into that level of detail? I know in the roll forming world, sometimes we do, because we're really trying to push the limits of how fast we're moving material through, and if we're doing really long feed rates or things like that. Tell us a little bit about that.
So in simple terms, the XL and the decel rate is what we're referring to. So to answer your first question, we do not have a lot of customers historically where that's been an issue or an area requiring adjustment. Like anything, for every action, there's an equal but opposite reaction. Changing the XL and decel can have a detrimental effect as well as a beneficial one. So it's something that very few customers mess with, because they don't want to have a negative impact on other aspects of how the machine operates. That being said, the advent of servo presses has really brought that to the forefront, where historically it had kind of been on the back burner for most folks for the reasons I mentioned. With a servo press, that window is far more flexible, and you're no longer dealing with simply 360 degrees. So without getting too far ahead of myself, the XL and decel will impact how quickly you can move the material and how quickly you can slow the movement of that material based on the degrees available for not only feeding the material into that point, but also getting the tooling engaged, getting the tooling removed before you have that next movement. With a servo press, what's increased greatly there is the XL and decel effect on it, because you're no longer dealing with a 360 degree window. You could be dealing strictly with a 180 degree window, and in a pendulum mode, they're only running basically at the bottom of that circle. So you're only running basically half of that rotation instead of a full rotation. So the time afforded you to make a movement with the feeder then becomes directly tied to that acceleration and deceleration rate. So it is something that is growing in adjustability for customers as they gravitate more towards servo presses than the mechanical presses of yesteryear.
Yeah, I had an application which you're referring to, and I think the term was press angle.
Yes.
Was the amount of stroke that you have available for you to move the material, and then it had a very fast application. It was a 24-inch feed at 200 feet a minute, and we had tried to explore all the avenues of maximizing the press angle, which, as you said, 180 is pretty safe, but then we were getting into the 270 range, and then we were also playing with trying to get the acceleration rate of the servo feeder to maximize, and it just became so dangerous because you were at the max of every aspect of feeding that we ended up just abandoning the whole idea. It was just too risky.
And conversely, you have a similar issue if you're doing a cut to length line as an example, where you might be accelerating and decelerating a feed length of 240 inches. So we tend to think of speed as it pertains to the shorter feed lengths and the faster strokes per minute versus a longer continuous feed length. So there is, again, a benefit on both ends of that spectrum.
Mm-hmm.
Well, thank you too. I appreciate all the information that you've shared with us today. On behalf of Charlie and Kevin, I'm Brian Kopack, and thank you for tuning in to today's Formtek Talk. See you next time. So hopefully our discussion on servo feeders was helpful to you. As you can see, there's definitely a number of things to consider when selecting a servo feeder for your roll forming process. Please know that we're here to help as you make these evaluations. So please don't hesitate to reach out for a consultation. Again, the best place to do so is through our website at formtekgroup.com. There's absolutely no obligation. We'd love to understand what you're looking to do and see how we can help you achieve your objectives. For now, thanks again for listening. On behalf of Kevin Enos and Charlie Burgess, I'm Brian Kopack. Join us again for the next episode of Formtek Talks.